Hi, I'm going to go over the first example for graphing rational functions. So the first thing we're going to look at is for the fraction negative 4 over x, y equals negative 4 over x, we are going to look to see what makes the denominator 0. So in this case, it is just when x equals 0. That will give us our vertical asymptote. So we need to identify the vertical asymptote, horizontal asymptote, domain, and range. So even though this didn't ask us to graph, I can go ahead and make a little sketch of this graph. So let's see. I'm going to make a little sketch over here. Just going to draw an X and Y axis. And the first thing I'm going to do is identify the vertical asymptote. So if you look here, a vertical asymptote is determined by the denominator, and so we can see that x cannot equal 0. That is actually our domain. So our domain is going to be all real numbers where x cannot equal 0. So I'm going to go ahead and draw a vertical asymptote at the line x equals 0, which is a vertical line that looks like this. So this is the line x equals 0, and it is also our vertical asymptote. So we can write vertical asymptote as v dot a for vertical asymptote, and that is x equals 0. Now, if you look at the equation, if x will never be 0, then the only number I could input here is any number but 0. So this whole fraction right here, negative 4 over x, which is what y equals to, our output, that will also never equal 0. So therefore, we have a horizontal asymptote at y equals 0. That means we have a horizontal line y equals 0, so I'm writing the horizontal asymptote, and that will be this dashed line right here. So asymptote is where the graph is going to approach but never touch those lines. So we have a vertical asymptote at x equals 0, at y equals 0, and now what does the graph look like? So I know it didn't ask us to graph it, but let's see what the graph looks like. So we can make a little table, and we already know that at x equals 0, we have that this is undefined. So we could just put undefined. And also, we want to see what happens close to 0. So if I plug in a number close to 0, let's say positive 1, then at positive 1, we will end up, when x is positive 1, we will end up with y equals negative 4. So I'm going to go ahead and sketch that point. When x is positive 1, so let's say positive 1 is somewhere around here. This is a sketch. Y is negative 4. So that will be a point right here. What happens when x is 2? When x is 2, plug in 2 into the equation, we have negative 4 divided by 2. That will give us negative 2. So I'm going to put a little point when x is 2, y is negative 2. So let's say y negative 2 is somewhere here. So we will end up with a point over here. Now, if you notice from when we did the Desmo activity, this is going to be a curve that's going to go through these 2 points and approach our asymptote. So it's going to look something like this. Let's go ahead and look at what the left side looks like. So I just did right of 0. So this is right of 0. Let's go ahead and graph left of 0. Left of 0, I'll put it over here. I'm going to go ahead and plug in numbers such as left of 0, negative 1, and negative 2. So I'm going to make a little table, and I will put in, it's not really drawing this. All right, so I want to see what happens at when x is negative 1 and when x is negative 2. So I'm only checking a few points because I already know what this graph looks like. So at negative 1, when we input it into the, so going back, when we plug in -1 for x, we have -4 divided by -1. That ends up being +4. And when we plug in -2, -4 divided by -2 is +2. So let's go ahead and put those points on the graph. All right, so plugging the ordered pair, when x is -1, y is 4. So I'll put a sketch. Y is 4 somewhere up here. And when x is -2, y is +2. So that will be somewhere here. So when I draw the curve, I'm going to draw it through these 2 points, and it's going to be curving and going towards my horizontal asymptote and going above towards my vertical asymptote. So we have a hyperbola for this equation. Now, this is a sketch, so you can check it on Desmos or check it on a graphing calculator. But next we want to talk about the domain, and we want to talk about the range. So the vertical and horizontal asymptote actually help you determine what is the domain and range, because we said that x cannot equal 0 right here, which is the vertical line that we have here means that the graph will never reach x equals 0. So our domain is, if we set it very simply, we can say all real numbers where x cannot equal 0. So it could be any number in the whole wide world that's a real number except 0. And our range is also where our horizontal asymptote, where the graph will never reach. We will say the range is y cannot equal 0, but it can be any other number but 0. So we can say all reals except 0 for the domain, and all real numbers for the range except for 0 for y. And that pretty much concludes this question.